Welcome back to another video. This is the latest update. Pulsars, like the one seen in this artist's concept, are quickly spinning neutron stars with extremely strong magnetic fields that generate powerful bursts of deadly radiation and high-energy particles. In a recently published study, astronomers investigated the habitability zone around a pulsar for the first time. Pulsars are some of the strangest and least understood objects in the universe. These city-sized stellar cores are not only as dense as a backpack stuffed with Mount Everest, but also can spin as fast as a top. Furthermore, thanks to their insanely powerful magnetic fields, pulsars energetically funnel particles to their poles, which emit extremely intense, narrow beams of high-energy light. These bursts of deadly radiation plus surges of other damaging particles make the idea of living around a pulsar seem laughable. However, for the first time, astronomers have determined what it would take for a habitable exoplanet to survive the harsh conditions of a pulsar system. And as it turns out, it only takes an atmosphere, albeit a very, very thick one. In a study published December 20 in the journal Astronomy and Astrophysics, researchers calculated that the habitable zone, the region around a star where liquid water can exist for an exoplanet around a pulsar, could be as large as the orbit of Earth around the Sun. However, the researchers stressed that this requires the pulsar planet be a super-Earth, capable of sustaining an atmosphere up to 1 million times as thick as our own. Since a pulsar is actually a type of neutron star, a collapsed core of a massive Earth star, it no longer produces heat through internal thermonuclear reactions. Because of this lack of a steady energy source, researchers needed to find another way that pulsar B1257 plus 12 could warm up its planets to water-friendly temperatures. Using archival X-ray observations taken with the Chandra X-ray Observatory, astronomers Alessandro Petruno, Leiden University, and Astron and Mikkel Kamal, Leiden University and Cambridge University, investigated the pulsar to determine how much energy it was releasing in X-ray light. Based on the Chandra data, the researchers calculated that the two super-Earth planets around the pulsar were receiving enough energy from X-rays to sustain liquid water. That is, as long as they have absurdly dense atmospheres. According to the study, if a planet around pulsar B1257 plus 12 has a thick enough atmosphere, it can absorb and convert the pulsar deadly X-rays and high-energy particles into relatively harmless infrared radiation, otherwise known as heat. However, the atmosphere would need to be so thick that the conditions on the exoplanet's surface would be similar to those found at the bottom of the Mariana Trench, the deepest part of Earth's oceans. Considering the Milky Way alone is estimated to contain around 200,000 pulsars, understanding how planets both behave and form around these objects is not a trivial endeavor. In future studies, astronomers would like to use the European Southern Observatory ALMA telescope to investigate dust disks around other pulsars, hopefully shedding light on the early evolution of pulsar-orbiting exoplanets. Thank you guys for watching this video. Do like and share this video. And don't forget to click the subscribe button for more such future updates. Thank you.